Most modern UI bugs are not random. They are predictable failures of how we build interfaces today. Layout shift, hydration mismatch, scroll jitter, breakpoint drift. If you have built anything even slightly complex, you have seen all of these. And here is the uncomfortable truth. You did not cause them. Your system did. You load a page. Everything looks fine for a moment, then it shifts. Text jumps. Images snap into place. Your hero section pops open after a delay. You resize the window, and now your layout is slightly off. Not broken, just wrong. 2 pixels here, 4 pixels there, and no clear reason why. You scroll and the parallax stutters. Elements lag behind your input. Animations that looked smooth in development suddenly feel unstable in production. And the worst part is these bugs do not feel logical. They feel random, inconsistent, and difficult to reproduce. So what do? We patch them. We add debounce functions. Resize listeners. One more use effect. Extra wrappers. Magic CSS fixes. We fight z-index wars. We tweak breakpoints over and over. We ship and move on. But nothing actually gets fixed at the root level. The same classes of bugs keep coming back in different forms. Here is what is really happening. Modern UI frameworks do not control layout. They negotiate layout with the browser. You are not telling the system where things go. You are suggesting it. Flexbox, grid, percentages, auto-sizing, intrinsic layout. These are all constraint systems. You define rules, and the browser resolves them. That resolution does not happen once. It happens repeatedly, based on changing conditions. After render, after content loads, after fonts resolve, after JavaScript runs, after the viewport changes. Your UI is not a fixed structure. It is an emergent result. It is constantly being recalculated. That is why hydration mismatches happen. That is why layout shifts happen. That is why scroll desync happens. That is why things feel stable one moment and off the next. The system itself is unstable by design. A lot of developers assume React fixes this. It does not. React controls state to UI mapping. It does not control space, position, or layout resolution. Even if your state is perfectly consistent, your layout can still break. Because the browser is still doing reflow, repaint, and recalculation underneath you. React makes updates faster, but it does not remove the underlying negotiation. It accelerates a flawed model instead of replacing it. At small scale, you can get away with this. At larger scale, it becomes a serious problem. Components behave differently depending on where they are used. Layouts break only at specific widths that are hard to predict. Animations degrade under real-world conditions. Teams spend more time fighting layout than building features. Eventually, you hit a wall where you cannot reason about your own UI anymore, because you are not actually in control of it. This is the breaking point where a different model becomes necessary. This is where the Lumenexus Framework, also known as FVLA, comes in. The Lumenexus Framework is not a styling system, and it is not a component library. It is a fundamental shift in how layout is defined and executed. Instead of describing constraints and letting the browser solve them, the Lumenexus Framework defines an absolute frame and computes everything inside of it. You establish a control viewport. That viewport becomes your source of truth. Inside that frame, position is explicit. Scale is explicit. Layering is explicit. Timing is explicit. Nothing is left to negotiation. Nothing depends on late-stage browser resolution. There is no guessing. There is no emergent layout. There is only a deterministic spatial system. This is the key shift. You move from a document model to a system model. From reactive layout to computed layout. From suggestion to control. Now all of those so-called random bugs stop being random because the conditions that created them no longer exist. Layout shift disappears because layout is no longer dependent on asynchronous content. Hydration mismatch disappears because the frame is identical before and after render. Scroll jitter disappears because scroll is treated as an input to a controlled system, not a trigger for layout recalculation. Breakpoint drift disappears because you are not relying on fluid constraint resolution that changes at arbitrary widths. Z-index chaos disappears because layering is defined intentionally within the frame. Even deeper than that, your mental model changes. You can now reason about your UI with precision. If something is wrong, you know where to look because the system is deterministic. That alone is a major breakthrough. Debugging stops being guesswork and becomes engineering again. The Lumenexus Framework, or FVLA, does not just fix surface-level issues. It removes entire categories of bugs at the architectural level. That is why this matters. This is not about saving a few milliseconds or making code cleaner. This is about eliminating instability that has been accepted as normal in modern web development. Now let's be clear. This level of control comes with responsibility. You are trading convenience for precision. With the Lumenexus framework, you own positioning logic, scaling logic, and responsiveness. If your system is poorly designed, the results will reflect that. And there are areas where the traditional document model still makes sense, such as long-form text and content-heavy layouts that rely on natural flow. But that does not diminish what this represents. Every major shift in computing has moved toward more explicit control when systems reach a certain level of complexity. That is exactly what is happening here. The current model does not scale cleanly for high-performance, highly interactive interfaces. The Lumenexus framework is a response to that limitation. This is why adoption should not be driven by trends or short-term gains. It should happen because this is a more correct model for building modern interfaces. As applications become more dynamic, more visual, and more performance-sensitive, the need for deterministic layout systems will only increase. This is not a niche idea. It is a direction. The Lumenexus framework excels in areas where instability is most visible. Hero sections, interactive visuals, parallax systems, application-style interfaces, and any environment where precision and performance matter. These are the areas where traditional layout systems struggle the most, and where FVLA provides immediate, tangible improvements. So the question is not whether the current system can be patched further. It is whether it should continue to be the foundation at all. Modern UI bugs are not random. They are the result of a system that was never designed for this level of control. The Lumenexus framework does not patch those bugs. It removes the conditions that create them and replaces the model entirely. At some point, continuing to fight the same problems stops making sense. The shift becomes inevitable. So the real question is, do you want to keep negotiating with the browser or start controlling your UI? Thanks for watching FrontEndSystemsLab. Please subscribe for more under the hood content.